So hello guys, this is another question from IIT JEE PYQ. The question is from the chapter circular motion here. Here is the question. A simple pendulum of length L and mass m is oscillating in a plane about the vertical line between the angular limits -5 to +5. Okay. For an angular displacement theta, that modulus of theta is less than phi, the tension in the string and the velocity of the bob are t and v. Okay, so it is an intermediate situation that is given in the question. We have to analyze it. The following relations hold together, hold good under some given conditions. Okay, so I will draw here the diagram what is given in the question. So this is our pendulum here. This is our pendulum and it is oscillating about this line, vertical line, and the angular amplitude of this pendulum is given. This length of string is L and this mass is m, and the angular amplitude is given as phi. Okay, so means at phi this velocity of the bob will be equal to 0. And now we have to take an intermediate situation here, like this is the pendulum and this is the vertical line. It is oscillating about it, and we will be taking an intermediate situation, that is what our bob is here. Okay, this is the length of the string and this is the theta angle, and it is given that this modulus of theta is less than the phi. Okay, that means it is an intermediate situation. So here I will be writing the forces acting on this mass m. So one will be in the downward direction, that is weight of this object mg, and one will be a tension force acting in this direction, that is what t, let us suppose. Okay, now if I draw this line and if this angle theta, then this angle will also be equal to theta, and the component of this mg along this line of tension will be equal to mg cos theta. Okay, and it is given that at this situation this bob is moving with an velocity of v. Okay, so if I write the circular equation of motion in polar coordinates, that f radial will be equal to mass into a radial acceleration. Here I will take this direction as the positive direction. This is our r cap plus r cap, and this is our negative r cap direction. Okay, so I will be writing all the forces that are acting according to this positive r cap and negative r cap. That means mg cos theta in positive r cap, mg cos theta r cap minus this tension in the negative r cap direction, so it will be negative tension into r cap, that will be equal to mass into acceleration in the radial direction is always equal to, as we know, that it will be equal to m negative of v square by r. Negative sign here is for negative r cap actually. Okay, so if I write only the modulus here, then it will be mg cos theta minus t will be equal to negative of m v square by r. R is equal to what? Here r is equal to the length of string, that is L. Okay, so here will be L. So if I take this negative sign here, then I can write this equation as t minus mg cos theta is equal to mv square by L. Okay, so this is our condition here. Let me call it equation number 1. Now now I will be talking about this theta cap direction. So this was the equation of motion I wrote in that r cap direction. Now tangentially I will resolve this force, then component of this mg along tangential direction will be equal to mg sin theta, mg sin theta. Okay, so here if I write the equation of motion in tangential direction, if I write tangential direction, then f tangential will be equal to mass into a tangential. Okay, and the value of f tangential is what? The force acting in the tangential direction, that is equal to mg sin theta only. Okay, so mg sin theta will provide the tangential acceleration here. So mg sin theta will be equal to m into a tangential, right? So m will be cancelled out here, and the value of a tangential will be equal to what? G sin theta. Okay, So this is our condition. Now we have to see the options here which are correct or not. So the first option is what? T cos theta is equal to mg. So here if I resolve this force tension in this direction, then this angle will also be equal to theta, and this component of tension will be equal to T cos theta, right? So here I cannot write that T cos theta is equal to mg because our body is not in equilibrium. That means T cos theta is equal to mg. It is not correct. It is correct when this body is not doing any type of vertical motion. So here our body is doing both vertical motion and the circular motion also, horizontal and both vertical motion. So in vertical line this body is not in equilibrium, so I cannot say that this equation is correct. So it will be incorrect. Okay, so our first option is wrong. Now coming to this part B, the magnitude of the radial acceleration of the bob is what? Okay, so the radial acceleration, here it is tangential acceleration. So the radial acceleration is equal to v square by L only, but if I write here tangential acceleration, then tangential acceleration at modulus of at will be equal to g sin theta, as we have calculated here. Okay, so this is the value of at is equal to tangential acceleration, that is equal to g sin theta, right? So if I think the situation there is incorrect option here. So here should be tangential acceleration and the value of this a tangential will be equal to g sin theta, right? Now coming to the C equation, that is what? T minus mg cos theta will be equal to mv square by L. So here is our equation number 1, as we have calculated T minus mg cos theta is equal to mv square by L. So this equation is also correct here. Now coming to the D part, T is equal to mg cos theta. Okay, that is not correct actually. This body is also doing this circular motion, so we cannot write T is equal to mg cos theta. So this equation is incorrect. So here if I substitute this as tangential acceleration in the option B, then our option B and option C will be correct. Okay, thank you.